Okay, so today we are gonna find a solution for this problem, and the method we are gonna use actually works for all exponents, so I'm gonna show it at the end. Okay, so first of all we have to know that the sum of all odd terms up to k is equal to the square. So we can replace the k squared by this. So let's just introduce another variable, another sum, L from 1 up to k of the odd terms, which is 2L minus 1. And then we can simplify this, because it looks worse, by just looking at how many there are. You can look at it from the top, so we don't need this anymore. We can just use k from 2k minus 1. So the odd terms of how many odd terms are there? There are n plus 1 and then minus k. So we get one term less every time. So that's an n plus 1 minus k. We can check that real quick. If we go, there's n times 3, and the first one is k equals 1, so there's 3, and the last one is k equals 2, so we get 1, exactly. And now we can, factorize this, and let's put parentheses around this, because this is a constant in the k world. And so this is equal to the sum of k equals 1 up to n of, let's see, 2k times n plus 1. Then we get minus 2k squared. And then we get negative times negative is plus k. And here we get, why did I do that? Okay, here we get minus n plus 1. Okay, so I mixed up the order, but it's fine. So you might notice that we got 2k squared here again, but that's actually a good thing, because it's 2 now and we can move it to the other side. So we are just going to do that. We don't need this anymore. We can just go with minus, plus 2k squared, is because we can pull it out of the sum. We get 3 times this. Then we just need all of the other terms. And let's group them in terms of k. So our first sum is just k. This is this term and this term. This is 2n plus 2 plus k, so that's 2n plus 3. And then the other sum is just the sum of 1. And you might know what that is. So first of all, we have plus, we need a minus here, and then we get n plus 1 in front of it. So we need a formula for this and a formula for that. Both of them are pretty easy. The first one is just 2n plus 3 stays. We get n times n plus 1 over 2. This is just the Gaussian method. I think that's the name. And for n times 1, that's just n times 1, that's n. So you get minus n plus 1 times n. And now we can pull some things together. So first of all, let's start with the 1/2 and factor out n and n plus 1. N and n plus 1, because both of these things have it, And then we get times 2n plus 3. And this is 2, because we have pulled out 1/2, So we subtract 2. And now we do just multiply 1/3 to both sides. So we get our final form of k squared equals to 1/6 times n plus 1 times 2n plus 1. And this method works for any exponent. You just need recursively the ones in the front, like every formula in the front. And here's the method. Okay, this formula looks really complicated, but it really isn't magic. Tell me if you want to see that. Otherwise, that's it. QED, and bye.